All right, guys, we're going to look at quadratic transformations one more time, but this time we're just going to be a little bit more focused on A. So remember that H inside the parentheses, that is going to shift right and left, and it doesn't follow that plus or minus rule. It actually does the exact opposite. And then you have K that's outside the parentheses that's going to shift it up or down, that vertical shift, and that does follow the rules, not inside the parentheses. So we're looking at that A that's out in front. And so that A is going to do two things. If it is positive, it doesn't change anything. It's still going to open up. But if it's negative, it's going to make that parabola open down. And so that's how you would word that, is that that negative would make that open down, which means it would look like an N. So if I had a negative A, it would look something like this, like an N instead of a U. But again, if it was plus, the A is positive, it's going to stay open up, no change, because remember, we're looking at the quadratic parent function. That's our basis, okay? That's what we're going to base everything off of. And then A is going to do a couple of things. So it can either make the parabola wider or it can make it more narrow. So if A is between 0 and 1, now I'm not just going to say less than 1 because that would include those negative numbers. And remember, the negative makes it open down. So the A right here is going to, if A is between 0 and 1, okay, that is going to make it a wider parabola. So it's going to end up being wider than the original parent function. And then if A is greater than 1, it's going to be narrower. So therefore, A is greater than 1, so it's going to be narrower or skinnier, and that's what we'll have there. Again, with the H, it's going to shift it right and left, so I'm just going to go ahead and mark that we already know that. It's going to shift right if it is going to be a negative, and it's going to shift to left if it's a positive. So I had to kind of like stop and think about that because it is kind of backwards. And then we have, this is going to be a shift. It's going to be up if it is, oops, that's a U. It's going to be up if it is positive, and it's going to be down if it is a negative. So all those transformations, put all those together. So here we have, now I know on your notes it's not colored, but on this one we have the graph of the quadratic parent function is in red. So that's the normal width. Okay, and then the graph of y equals 1/2 x squared is blue, and both are graphs. So we're going to describe that transformation. So notice that I don't have h and k. I'm kind of leaving those off to the side right now. I just am affecting a. So that's that a that's connected to x squared, and you'll notice that it is wider. So the transformation is that the blue function is wider. And so it is wider because we have that 1/2. Remember, if a is between 0 and 1, so it's a fraction, then you're going to have a wider function. Now, something that you want to be really careful about is if you have like an improper fraction, like 3/2. So that's going to be bigger than 1. It's going to look like a fraction, but it's kind of tricky there. All right, so let's look at the second example now. So now instead of 1/2, we have a 3. So the quadratic parent function is in red, and so that's the normal width, and you'll see that my blue function is 3x squared. You'll notice that it is skinnier, it's narrower. So this transformation is going to be, oops, wrong writing utensil. It's going to be narrower. Now, why is it narrower? Well, it's narrower because we have 3, and the 3 is larger than 1. So those are the two differences there. So we have wider if we have a proper fraction that is reduced, all that good stuff, and then we have narrower if it's larger than 1. All right, so let's look at this example here. So I gave an equation. We're going to find the transformations there. So I just like to start like left, move right. So The 1/2 here is going to make it wider. The -3 is going to make it shift right. So it's just going to shift right 3 units. You kind of see it, you might see it as 3 units, shift right 3, that kind of thing. And then the +5, so one more transformation is going to be up 5 because it is a plus. It's a shift up units. So those are the quadratic transformations. So again, we're looking at the newest one is A, and if A is a proper fraction, so it is between 0 and 1, then you're going to have a wider a wider parabola. And then if it is larger than 1, you're going to have a narrower parabola. And then remember, if it's negative, which we didn't see that much going on here in our examples, but if A is negative, then it would also make it flip down, or so sometimes you might see it as a reflection over the x-axis, or it's also going to be worded as open down. So that might be something that you want to pay close attention to.